They sold it as safe heat, so some of them get recalled for being heat. Space heaters are marketed as comfort, quiet, reliable, forget it's even on warmth. But if you read enough recall notices, you start seeing the same failure categories show up again and again, different shells, similar weak links. And to be clear, not every tower heater gets recalled, but the same failure patterns keep showing up in recalls. Welcome to Perfectly Wrong, the museum of designs that almost worked. And today we're doing every major space heater recall pattern, not brands, not model numbers, patterns. Because once you can recognize the pattern, you can recognize the risk. One rule for this tour: each exhibit gets one failure, one weak link, one design decision that turns safe heat into recalled and pulled from shelves. Let's start. Failure type 1. Tip over. A heater doesn't need a dramatic internal failure. Sometimes it just needs one bad angle. Exhibit 1. The tall ceramic tower. It looks stable. It feels modern. It looks like it belongs in a living room. And that's the trap. Tall bodies on narrow bases don't negotiate with gravity. A light bump, a pet, a cable snag, a carpet edge, and suddenly the heater's job changes. It's not heating air anymore, it's heating whatever it landed against. Exhibit 2. The oscillating tower. Now you've added motion. And motion loves weak points. A rotating head, a pivot joint, a base that twists, and a tip-over shutoff that has to work perfectly at the exact moment it matters. Oscillation is a feature that quietly demands engineering discipline. Tip-over patterns show what happens when that discipline slips. Exhibit 3. The personal desk heater. Small, light, easy to move, easy to place exactly where you want it, and easy to knock over without noticing because it's light enough that the cord can do the knocking for you. You don't even have to bump it. You shift your chair, the cable catches, the heater tilts, the heater falls. This is where personal comfort collides with basic stability. Exhibit 4, the wall heater. It doesn't tip, but it does invite risky context. Tight clearances, nearby towels, damp air, cords routed in ways nobody planned. The pattern here is simple. Real-world placement becomes part of the safety equation. Because homes aren't a lab, tip-over failures don't need a complicated chain of events. They need one moment of imbalance. And now we move to the pattern that doesn't fall, it just quietly keeps going. Failure type 2, overheat. Here's where it gets quieter, and worse. Not too much heat. Heat in the wrong place, at the wrong time, without a fast enough shutoff. Overheat patterns are what happen when the heater keeps doing its job, after the safety margin is gone. Exhibit 5. The fan-forced box heater. It's basically a toaster for air, an element and a fan that moves air across it. And everything is fine until airflow isn't fine. A fan that slows down, a fan that stops, an intake blocked by dust, a vent meeting a blanket. The heater doesn't suddenly become evil, it becomes predictable. Temperature climbs where it shouldn't, and a cutoff that should act immediately acts late. Or not at all. Exhibit 6. The compact ceramic heater. Ceramic is popular because it's efficient and compact. But compact design means the sensor matters. Where it sits, what it reads, what it misses, how quickly it reacts, what happens when heat builds behind a panel, not in front of it. Overheat recall language often boils down to one idea. The unit didn't shut off when it should have. Exhibit 7. The infrared quartz heater, bright tubes, radiant heat, instant warmth. Clearance isn't a suggestion, it's the safety design. Infrared doesn't need airflow to create a problem, it needs line of sight. Too close to fabric, furniture, anything that shouldn't be warmed like that, and you've built a predictable hazard. Exhibit 8. The mica thermic panel heater. Flat, minimal, quiet. The kind of product that looks safe because it looks simple. And that's the paradox. A flat panel can create one very confident hot surface. The design invites you to treat it like a harmless object, right up until you can't. Overheat failures don't require weird misuse. They require real life. Blocked vents, tight spaces, dust, time, and a shutdown system that isn't as fast or as reliable as it needs to be. Now watch what happens when the hazard isn't heat in the air, but heat in the parts you can't see. Failure type 3. Electrical. The outside says safe. The inside is where safety either exists or doesn't. Electrical recall patterns come from one uncomfortable truth. You can't see integrity, you can only design for it. By the way, if you have a space heater at home right now, you're not being paranoid for checking it, you're being smart. Because the pattern doesn't care how much you trust the product. Exhibit 9, the plug-in mini heater, convenient, portable, no cord on the floor. And here's the real phenomenon behind the metaphor. In some compact, high-power designs, the plug-in outlet connection can become the hottest point, because a slightly poor contact creates resistance, and resistance turns current into heat, right at the connection. So the heater isn't heating the plug on purpose, but a weak connection can make that plug area run dangerously hot. Exhibit 10, the heater with a detachable cord. Detachable cords look premium, modular, clean, but every connector is a promise and a potential hotspot. If the connection isn't tight, if the materials aren't rated correctly, if the design allows slight loosening over time, you don't get a dramatic failure. You get slow heat, the kind that builds silently. Exhibit 11, the mechanical dial switch. Clicks feel reassuring. Old school controls feel trustworthy, but mechanical switches can arc. Contacts wear, heat cycles, materials age, and a tiny invisible spark inside a housing is all it takes to turn a comfortable knob into an uncomfortable headline. Exhibit 12, the feature-heavy heater, remote receiver board, smart module, extra electronics. More features mean more wiring routes, more boards, more connectors, more ways for a wire to pass too close to a hot surface, more ways for strain relief to be slightly wrong. Electrical failures aren't mysterious. They're repetitive. They're what happens when one weak link repeats, while the outside stays confident and the inside gets compromised. And before we go on, here's the part that never fits inside a recall notice: the cost of repetition. In the United States, estimates put portable heaters at around 1,100 residential fires per year. That's roughly 65 deaths, 150 injuries, and about $51 million in property loss every year. And the leading factor isn't exotic engineering. It's simple. The heat source ends up too close to something that burns. That's why patterns matter, because when the same weak links repeat across millions of units, the outcome stops being bad luck. It becomes predictable. Now, here's where the safe-looking shell becomes the hazard. Failure type 4. Materials. When the housing becomes part of the problem. Materials recall patterns aren't about heat existing. They're about heat living where it shouldn't, and materials not tolerating the conditions of normal use. Exhibit 13. The fireplace-style heater. It sells cozy. It sells ambiance. It sells home. But decorative shells can trap heat in the wrong places. Panels that look like furniture, trim that looks like decoration, surfaces that don't look like heater parts, but behave like heater parts. The failure point is often simple: materials and geometry that turn normal operation into a hotspot. And here's your mid-roll wow moment. Most people assume the safest heater is the heaviest one. Old school, familiar, oil-filled, proven, but proven doesn't mean immune. Exhibit 14, the oil-filled radiator, heavy, stable, quiet, familiar, often safe, but the controls still decide everything. Thermostats drift, cutoffs fail, and old-school safe becomes quietly wrong when the safety system doesn't age gracefully. Exhibit 15, the underdesk foot warmer. It lives near fabric by design, rugs, socks, blankets, the exact stuff that doesn't like uncontrolled heat. So the design has to win that fight every day. Clearances, shielding, venting, shutoffs, and a housing that won't deform when it gets warm. If any of that is weak, the product doesn't just warm feet. It warms whatever gets pressed against it. Exhibit 16. The baseboard-style portable heater. Long vents invite one thing: blockage. A bag pushed too close, a curtain edge, a bed skirt, dust buildup that quietly becomes insulation. And insulation is great, until it's in the wrong place. Material failures don't start dramatic. They start quiet. And then the shape doesn't stay the shape. One more pattern. And it's the one that looks like nothing happened. Until it did. Failure type 5. Placement. The human factor. This one isn't always a defect. It's the part safety reports keep repeating. Where the heater ends up matters as much as what's inside it. Heaters are often involved in incidents when they're too close to things that burn. Fabric, clutter, furniture, curtains, especially in small rooms where a little closer feels harmless. So here's the honest version. Some features that feel comforting. Quiet operation, compact size, set and forget controls can make it easier to treat a heater like furniture. Not because anyone is trying to trick you, because that's what humans do when something feels normal. Exhibit 17. Quiet bedroom heat. The quieter it feels, the easier it is to forget it's still a heater. Exhibit 18. Kid safe. Pet safe shapes. Rounded corners don't cool hot surfaces. Friendly form doesn't erase wattage. Exhibit 19. Compact, but powerful. When you squeeze watts into less space, you squeeze your safety margin too. Exhibit 20. Smart, app-controlled heaters. Timers and apps don't change physics. They change attention. They can make it easier to trust the wrong thing. Placement is the failure type that never looks like a failure. It looks like routine. The pattern reveal. 4 safeguards that keep coming up. After enough recalls, the pattern becomes almost boring. And that's the scary part. Zoom out, and you can group most recall narratives into a few recurring safeguards that have to be executed well every time. 1. Stability, plus a reliable tip over shutoff, not just has a cutoff that works when posture changes. 2. Real overheat control, sensors placed like it matters, shutoffs that react fast, designs that tolerate blocked vents because real homes block vents. 3. Electrical integrity, wiring routes that respect heat, strain relief that protects the cord, connections that stay cool, switches that age without turning into hazards. 4. Materials and clearances that hold up in normal use. No surprise hotspots, no deformation under expected heat. Different shells, same pressure points. So if you're wondering what every major recall pattern actually means, it means the same weak links keep reappearing until they're forced off the shelves. So yeah, that's the museum tour. Subscribe if you like your home the way it is, unmelted,